Imagine a gigantic dam holding back an enormous lake of water. Now, picture this. During a heavy rainstorm, a small section at the top of the dam lets water spill over, on purpose. At first, this might seem like a mistake. Why would engineers allow water to flow over a dam that is supposed to hold it back? The answer is in a brilliant engineering concept called design failure. It's not a mistake. It's a safety feature. Actually, engineers sometimes design parts of a structure to fail on purpose so that the entire system stays safe. In this video, we'll explore this fascinating world of engineered failures, where sacrificing one piece can save the whole thing. Let's go back to that dam example. When rain pours down hard and fast, water levels rise everywhere, especially in the reservoirs that dams are holding back. If the dam doesn't have a way to release some of the water, the pressure could become too much, causing the entire dam to completely break. That's why dams have something called spillways. A spillway is like a safety valve. It's a structure that channels extra water away from the dam. By letting a controlled amount of water flow out, spillways prevent a much bigger disaster. It's like choosing a small mess to avoid a giant catastrophe. So, engineers design these spillways to relieve some of that pressure on a dam. And to do this, they calculate the amount of water that would fall during a storm based on historical rainfall data. Fun fact, the Three Gorges Dam in China has the world's largest spillway. It can handle almost 30 million gallons, or 110,000 cubic meters of water every second, enough to fill 45 Olympic-sized swimming pools in 1 second. Now, imagine a different kind of danger, like a fire in a building. Here, the idea of design failure works in another way. Many fire safety systems use a small piece of metal called a fusible link. This link melts when it gets too hot, which triggers super safe fire doors to automatically close or sprinklers to spray water. So, the link itself is what fails, but that failure then activates life-saving systems. It's like a selfless hero sacrificing itself to protect everyone else. Fun fact, fusible links have actually already been used for fire safety for over 140 years. They were first popular in factories in the late 1800s, back when sprinklers were a brand new invention. This idea of letting one part fail to save the rest also happens in the world of electricity. Think about the circuit breakers in your house. These devices stop the flow of electricity if there's too much current. If the breaker didn't trip, the wires in your walls could overheat, causing a fire. So, when your lights go out because of a tripped breaker, it's annoying, but it's much better than your house catching fire. Fun fact, Thomas Edison invented the first circuit breaker in 1879. The same year, he created the first practical light bulb. Another surprising structure that has engineered failures built in are bridges. Have you ever noticed small gaps in the road while driving over a bridge? Well, those are called expansion joints. They allow the bridge to stretch and shrink as temperatures change. With these joints, the bridge could crack or even break over time. In extreme cases, parts of a bridge might be designed to fail on purpose during an earthquake to protect the rest of the structure. For example, engineers might allow the surface of the bridge to buckle so that the main supports stay intact. This way, the bridge can be repaired instead of being completely rebuilt. Fun fact, the Golden Gate Bridge in California uses over 250,000 individual cables to stay flexible and strong. Each cable is part of its fail-safe design. So, how do engineers decide which part of a system should fail? It's not random. Engineers study the system carefully and identify where failure would cause the least harm. This process is called risk analysis. They use computer models, simulations, and real-world tests to figure out the weakest point that would cause the least amount of damage. If a system is too weak, it fails too easily. If it's too strong, the failure might happen somewhere more dangerous. It's a delicate balance that takes a lot of planning. Fun fact, Engineers today use super advanced simulations that can predict exactly which part of a structure will fail first, all the way down to a specific bolt. Engineered failures aren't just for structures, they're also part of planning for disasters. In some cities, engineers and city planners create areas that are specifically designed to absorb water from floods. These areas, called floodplains, act like giant sponges, soaking up water to protect cities and towns from flooding when there is a lot of rain. It's not ideal for the people living in floodplains, but it helps prevent even bigger disasters in more populated areas. And even in outer space, engineers use these types of sacrificial designs. Rockets are built with parts that are meant to fall off during the launch. The first stage of a rocket actually burns up its fuel and then detaches, allowing the rest of the rocket to keep going. This intentional failure is needed to make space travel possible. Without it, the rocket would be too heavy to reach orbit. Fun fact: the Saturn V rocket, which carried astronauts to the moon, had 3 stages, and each one was designed to fail and separate during the flight. So, why do engineers go to all this trouble to design things that fail? Because perfection isn't always the goal in engineering. Resilience is more important. And resilience means creating systems that can handle problems, adapt, and recover. Engineers think ahead, just like a chess player planning several moves in advance. They know that sometimes sacrificing a small part is the best way to protect the whole system. The next time you see a spillway at a dam or a tripped circuit breaker, you'll know there's more to the story. These systems aren't broken. They're doing exactly what they were designed to do. They're failing in the smartest way possible to keep everything else safe. And that, in the world of engineering, is a brilliant kind of success. Thanks for watching. We hope you enjoyed learning about why engineers design things that fail on purpose. What other things can you think of that are designed to fail? Let us know in the comments below. Be sure to check out our other videos about other engineering designs. And remember to like and subscribe to our channel because engineering is for everyone.